Well, this is Bill Foote, and we are in week one of a strategic decision intelligence course. I think I got all of that out. And really, it is applying inference and inferential methods from Bayesian decision analytics to system dynamics models, all of which are simulations. The entire process is one long simulation. We are in week one, as I said, and this week we are beginning to position ourselves with the base model of interaction between one group and another. The primordial system for this is the predator prey system, which was modeled by several people, but especially Lotka and Volterra in the 20s, 1920s, that is. So, with this kind of a model, there's interesting applications which we can begin to read. Some of this is here in terms of the Scholarpedia article. This is the System Dynamics 101 website. Several videos here, and this video I promise to be fairly short. What I want to accomplish is taking a Vensim model into Excel. You could also do it with Google Sheets. I use Excel mainly because I like to make named variables. It's a little bit easier for me to do it in Excel rather than Google Sheets, but we'll work on that. Both are quite equivalent. They give you the same results, and we can do pretty much the same operations in both platforms. So here is the wolf meets moose model in Vensim. I've already got it brought up here. Let's bring it up here. Don't worry about what's going on the right here. I want to worry a little bit more about what the structure of this model looks like. We have an accumulator, a stock variable called moose, and another stock variable for wolf. And we're modeling and representing these stocks as accumulations of customers over time. They take from one another. It's an interaction model. You can make this model a collaboration model just as easily, but it's usually featured as a competition model. There's an input flow and an output flow for mooseco customers, and the same for wolfco. You can attach whatever meanings you want. The sliders are very helpful here in playing with the model, literally playing with it. See what works, see what doesn't work. We have an initial number of mooseco customers as well as wolfco customers. We have acquisition rates, we have switching rates. So we're very much in the revenue side, the model of revenue growth of a value program of some sort. But this is, again, highly interactive. And what we want to do is take this model into uh, Excel. And the way to do it is to go to the left here, press this icon, the red one. We have all of the equations and all of the standing data. A stands for auxiliary, S will stand for stock, and F will stand for flows in the system Vensim setup. This is also what Duggan and Andrade do in their work. That's also cited in the course. The view, we do a select all, do a copy, and paste into an existing spreadsheet. We already set up the spreadsheet, and we just plop it here. Control V will do that. And then we do a little bit of cutting and pasting. In spreadsheets and other places, we get data, but we need to transform it into data that we can then use within the platform. In this case, the goal is to create named ranges for each of the auxiliary variables, as well as two more variables, which will define the time steps and the initial time. We're also going to have one more, and I'll show you the inputs here. It'll be time t, which is 24 months in this interpretation. We go back to the model here. You can see we use left, right, lengths, and so on to play with the business of getting rid of the parentheses 0, 1, the space, and the equal sign. All of that produces this strip of tokens, a initial moose, and there are 30 of them. And this just brings up that number. And we just copy and paste this all the way through, and you can see the results. Down here we have some other interesting things where we have formulas. Now these formulas are missing a very, very important multiplication in which each one of these occurs across a time step. So we have to multiply each of these by delta t, if you will. We just have to remember that. That is true of all of the flows. One delta time step is all we need. And then with the initial time and other things, we have an integration. We'll see how the integration works. It's just an accumulator. It's really a first order Euler approach to what effectively are the differential equations that are inside of all of this. So we can see there is a bit of one minus another going on in the integration, the accumulation of mooseco and wolfco customers. So that's the basic model. Vensim then can be produced, and this is just a copy and paste of the screen of the print screen of the Vensim model, this Vensim model right here. Let's pull that in, and that's good for documentation. We note the shapes of the wolfco customer and mooseco customers, and we note these here. This is what we're trying to replicate within Excel in this case. So back to the Excel model. This is very mechanical at this point. A couple of features here. Different tasks deserve different pieces here. All aspects of good model development where we basically sequester all of the major tasks. For example, graphs will look like this, and the simulation will look like this, and the inputs will be taken directly from where they came from. And that's within the context of this model drop-in from which we acquired from Vensim. Cut and paste, yes, but from here on we want to make sure there's some data integrity. Now you can write a program to send this to a file and then import this file, this data here from Vensim, import this file into Excel. We can build all of that automation, which would be quite useful for two reasons. One, machines do that better than humans, first of all, and secondly, operational risks, stubby fingers, and so on. So we have to keep all of that in mind as we go forward. Documentation is critical as we have this component of documentation. We might want to write some notes about this and this construction and what it means and how we're using it. Inputs, these are the inputs that we're going to be using. Notice over here, named ranges have already been established based upon these numbers. Now we may want to change this to these, because if we want to change these, we want to make sure that it's associated with a named range. Okay, so that's a minor piece, but an important piece of engineering. The simulation itself needs to be constructed, and it's quite straightforward. In this model, we have a variable called t, which starts out at t0 and ends up down here at t equals 24. We're using months, and we're using a very fine grid. It's a solid brute force grid. Love these because we can make it as fine or as coarse as we want. Notice we're using an if statement here. If the previous time is plus the step is greater than the final time, return a blank. Otherwise, proceed ahead. Okay, so this allows us to parameterize the A column within the confines of the parameters that we have set, the values we have set for timing. Remember that F stands for flow, and so we have flow in, flow out, flow in, flow out for each of the two stocks, the mooseco stock and the wolfco stock. Okay. We can get these again directly from the model, which is again inferential integrity about what we're even talking about, namely the names of these variables. But at time 0, nobody's acquiring, nobody's switching. Okay, but we do have 30 mooseco customers and 4 wolves. All right, so this is the predator prey, the hare, the Canada lynx, and the and the wolf. Okay, this is out of Hudson Bay, Canada. Yeah, so Canada, Hudson Bay data from a long time ago, showing very dynamic, interactive, and complex systems, organic systems, as Locke talks about it. So that very first line is very straightforward. It's just the initial values. And then we're going to accumulate and deaccumulate these values as we go forward. So let's see how this works. We have a moose acquisition rate times the previous moose level times the time step. Okay, and that's critical. You got to have that in there or this thing just blows up. It's partly the way we have parameterized the acquisition approach and the switching approach to measurement. It's in terms of months, and these are fractions of months. So the step is in months. Okay, so it's a fraction of some longer time frame. And then we do the same with switch. Now note in this one, it is times S moose and S wolf, where this is where the interaction occurs, where there is a switchback, and here it is where the wolf affects switching of the moose. Okay, so size of the wolf pack invading your customer space matters to how many mooseco customers switch out of this stock of current customers. Okay, that's part of the model. That's where the F2 and G2 come from. In the acquisition side, we have a similar but even more complex interaction for wolf acquisition. The wolf acquisition rate times the number of wolves, yes, from the previous step, but it's now also times the moose switching rate. That's how we acquire the, and this is the predatory part of this model. That's how we acquire mooseco customers. We offer them a better deal, of course. And all times a time step. And finally, wolf be gone, all right? Wolves just die out, yes. Um, Maybe there is a predatory virus that would affect the wolves in the wild. In our case, maybe there's an innovation effect that deprecates the wolfco organization itself. So we can again think about these things as we model. But again, G2 is pulled in the time step, and this is how this works. But look at this. This is very simple. This is like an inventory problem. We have a previous plus in minus out. In is B3, acquisition. Out is C3. It is as simple as that arithmetic. Same with wolf. Previous plus in minus out. And thus we have, again, if we're modeling inventories of customers, this is how we would do it, or just about anything from an inventory point of view. We then just simply copy and paste all of this down. 12,001, because there's a zero up there, 12,001 entries in this particular simulation. And then we build a graph. Now, the way we build graphs is we do it dynamically. We state a title, in this case for x-axis, y-axis, and we might want to put vertical lines or horizontal lines in which case we would have to state their coordinates up here somewhere. So we build a simple graph. This graph is just, see, notice chart design comes up, is just a scatter plot. Now that's probably my go-to graph every time. Now you can build bar graphs and line graphs and so on, but I need the control over the graphical process and what I'm overlaying. In this case, two different curves. So if we go to the moose and edit it, you can see what's inside here. mooseco customers, the series name. Okay, I gave it that name because I want it to appear this way in the legend. So the series name's important for legending and documentation, really, and talking to somebody about what you're doing. The series X values are down here. Notice they go from 0 to 12,000. I have to fix that eventually. That really should be 0 to 24. Okay, but it doesn't want to do that, although it is doing it over here very nicely. And there are 12,001 of these. And the Y values are going to appear on the vertical axis. Okay, and so we don't mess with that. Same thing with the wolfco situation. And now we have a graph which shows something which I believe replicates the phasing. Now the phasing means when do the troughs and peaks coincide or not. Okay, so we have some very interesting dynamics going on here. We have lots of customers and lots of wolves coming up and taking away from the customer base of mooseco and back and forth. Now notice it just goes on like this forever. Okay. There is a limit to this predation that would be the next model after this. But what I wanted to demonstrate was simply how we take a Vensim model into Excel using Vensim data, in this case, transforming that data into something that Excel can read, which is namely these values of strings and numbers, have an input area, specify the time, the timing of the simulation, have a separate tab, a separate worksheet for the task called simulate, And you can see the simulation is very, very straightforward. We are actually solving for a system of differential equations. Who would have thought? And then graph it. Graph it using dynamic variables. Notice that when you light up that text box for that graph, you are pulling in the title, which is in C2 here, and the same for these. And that is not a nice to do practice, a must do, strongly recommended practice. Or else the possibility exists that when we go in here and play with this and put in our own data off the cuff, nobody can possibly audit it. It's part of data stewardship, it's part of ops risk, it's part of doing a good piece of spreadsheet engineering, which is what we have here. So that's all I have for this. Vensim, Excel, by way of a simple, and I hope this development helps us understand the accumulation process that goes on with these stock and flow variables as we have them. This is very similar to frequency and cumulative frequency in statistics, very, very similar. And that we are actually solving a system of two states, the mooseco customer state and the wolfco customer base state. Two different states with lots of things happening interactively with them. I'll leave you with that. Thank you very much for your kind attention, especially this first week. And I hope this particular excursion encourages you to build these models, not just in Vensim and in R that we're going to primarily use for a lot of our heavy lifting, but that we can also use these to very, very good effect in a number of situations right in front of clients. So I'll leave you with that. Enjoy your day, and remember to encourage each other. Today, pick up the phone and encourage each other. That's what we need more than anything else these days, every day. Thanks.